Okay, everyone, let's get going with this topic. And so what I want to talk about is this unit is all about triangles. Okay, and so when we talk about triangles, I want to know from the chat, what are the different types of triangles that we kind of talk about in mathematics? Primarily, what are the three different types of triangles that we primarily talk about in mathematics? So pop your answer into the chat. So I see a couple of things coming through. So we talk about the main things, the main kind of things we differentiate between are acute angle triangle, and then we talk about an obtuse angle triangle, and then we often talk about a right triangle. And I can see in the chat that there are also more things about things like isosceles, scalene, and all that, and that's also another way of classifying triangles. As we go forward into this topic, which is really just about solving triangles, solving for angles and sides, it's important that you understand what an acute angle triangle is. So basically, in an acute angle triangle, all the angles will be less than 90. They're all smaller than 90. An obtuse angle triangle has one angle greater than 90, the one that looks like it's bending over backwards. And then a right angle triangle has a 90-degree angle inside the triangle. And so that is an important idea. Now, it's true that there are things called scalene triangles, which are when all the sides are a different length, all the angles are different, and isosceles and equilateral. And that's got to do with the length of the sides. And that's true too. Now, the other thing I want to tell you about is how we name our triangles. And normally, what we do is we name our triangles with the pointy bits or the vertices we in capital letters. So I'm going to have my triangle like this. It's an ABC, then triangle DEF. And what comes after F? A, B, C, D, E, F, G, E, F, G. So G, H, I. So we name triangles by using the capital letters for the vertices. Now, there's another convention that we use to talk about the sides. Does anybody know, would anybody like to put their hand up and tell me, how do we talk about the sides in a triangle if we've named the corners by capital letters? I want to know, there's a bit of like language, we have to get our kind of rules for the road in place. And so I want to know from, if somebody could put their hand up or someone can put in the chat, what is the way we talk about sides? How do we identify a particular side in a triangle? Who has an idea? So maybe, so if the big letters go with the corners, what do you think this side over here is going to be called? So you're right. Okay, so if we're talking about the hypotenuse and the opposite, that's important. But actually, what I was thinking of is, have you seen this thing before where the little letter is the side opposite the angle? And then the big letter, so this will be B, and this side over here will be C. Give me a thumbs up if you've seen that way of describing sides of a triangle. So what we do is we give the big letters to the corners or to the vertices, and we give the little letters to the side opposite that big letter. Okay, so if you haven't seen that before, don't worry. That's why you're here. You're here to learn about how we talk about triangles. But in this section, we could call this side over here, we could call it with capital letters AB, which means that's the side going from vertex A to vertex B, but we can also call that side C, little c. And the reason we like using little c is that it's just quicker, and also it shows us the relationship between an angle and a side opposite that angle. So using the same idea, if I was naming my sides in this triangle, I could name this EF, the quicker way to do it would be to call it D. We call this one F, and we call this one E. Now, what do you think I'm going to call this side over here? The question mark. What is going to be opposite? What is going to be in the place where the question mark is? Yeah, it's just going to be G. And then what is going to be there? What's going to be down here? Yeah, it's just going to be I. And over here, this is going to be little h. Okay, so when we talk about triangles, we need to know that if we see two big letters next to each other, that does mean a side, but sometimes, and this can cause a bit of confusion, the length or the side GI is actually the same side that we refer to as little h. And little h, or little letters in geometry and triangles, will always refer to sides. And that's just kind of what I wanted to start off with. Okay, give me a thumbs up if you feel like you follow that logic. Give me a thumbs down if you feel like you don't follow that idea. Okay, now something else that's important about triangles that I want to point out is the biggest side is always opposite the biggest angle. So I'm going to concentrate now on the obtuse angle triangle. The biggest angle here is the angle H. It's greater than 90. It's the obtuse angle. And so because this angle is the biggest angle, the longest side is going to be opposite the biggest angle. And then if I look at the smallest angle, which of these do you think is the smallest? I think the smallest angle is over here, which means the smallest side will be opposite here, and so it'll be there. And then if we talk about let's say like, let's make this one over here, make it like a empty dot. Let's make it like an empty dot there. We often talk about the length of sides. So when we have a triangle, if all the sides are of a different length, what we do is we indicate that by putting like striped lines like this on the side. And so these are the symbols we use to indicate that all three of these sides are of a different length. Whereas I might, in this question, because it looks like it's an equilateral, you would see these lines and they would say that all three sides are equal. And so that's another bit of notation that I want you to get used to. Give me a thumbs up if the idea of showing visually that the three sides are of a different length using these little strokes on each side makes sense to you, and the idea that the biggest angle is opposite the biggest side. Just give me a thumbs up if you follow that. Okay, so that's enough basic language for today, but just remember, whenever we deal with triangles, often you'll get these types of ways of doing things will come up. Okay, fantastic. Let's move on. So one of the first most fundamental ideas in solving triangles is, what are we solving for? And primarily when we solve a triangle, we're trying to find either a missing angle or a missing side. I want you guys to find me the value of x for that acute angled, not even acute, it's an obtuse angle triangle, but find me the value of x. And if somebody thinks they know what the answer is, I would love you to raise your hand and let me know how you found the unknown value. What is the value of x in this case? So I see lots of students are putting in the chat. Who wants to justify or tell me why it's, students are saying it's 25 degrees, which I think I agree with, but how do we know it's 25? Yeah, Tegavatso, what do you think is behind figuring out what is 25?
Sir.
Hello.
I got 25 because we all know that sum of angles of a triangle add up to 180 degrees. So yes. I subtracted 120 and 35 from 180, then I got 25.
Perfect. That is exactly. So triangles will always add up to 180. And so if we know two angles, we automatically find the third. So well done, Segabatso. The other thing that we need to do in geometry is we always give a reason. And so because we use the fact that the triangle adds up to 180, I say sum of angles in triangle. There are a couple of variations, but as long as you give some sort of reason justifying how you got the x was 25. Okay, let us do another one. I want us to try and do question D. So in question D, you are given a triangle that looks like that. I want you to figure out for me the value of x and the size of these two angles afterwards. Let's give them some names. We'll call it A, B, C. So over to you guys. Can you find the value of x using the idea from the previous question? And then once you find the value of x, can you tell me the size of angle B and the size of angle C? So I'm going to give you some time to work on this, but if you are unsure, don't be afraid to put a question in the chat for Kia or for me, and then or to raise your hand so we can have a conversation, because we know lots of students will benefit from hearing the question. So I think the key step is to know that this is equal to 180. And then how do we work with that to help us? Yeah, I see lots of students are saying that x is 16. And I agree, because if I divide both sides by 5 here, I get 16. Now, what is the size of angle B going to be? And what is the size of angle C going to be? That's what I want to know next. So we have to use the 16, and we have to put it back over there, and we have to put it back over there. So what are we going to get? 2 times 16 plus 10, which would be 42 for B. And then what are we going to get for C? I think we're going to get 3 times 16, which is 48 degrees. Yeah. Okay, so when we solve triangles, one of the main ideas that we always need to remember is that a triangle adds up to 180. And whenever we've got two angles, we can always find the third, or we can find the variables kind of inside the triangle. Okay, let's do another one, which is similar to this. Let me actually do something like, let me find something else, maybe something interesting. Let's do this one. Okay, B. I want you to solve for me for B. And in order to solve the triangle B, you have to find the value of X and you have to find the value of Y. So over to you guys. Can you find the value of X? Can you find the value of y. So because these two sides are equal, this is an isosceles triangle. And so this angle over here and this one over here must be the same size. They must be 44 degrees. And the reason we say is angles opposite equal sides. So these angles are opposite equal sides, which means that x is 44. This is an isosceles triangle. Now that gets us x. What about y? What is y going to be? What is y going to be? Well, I suppose I could write in that this is 44. But now, oh, wait, all triangles add up to 180. So I could just say this. And then I'll give a reason. And the reason is sum of angles in a triangle. That's how I know what that's going to be. And I should get, well, that's 88. So if I take away that, I should get 92. Yeah, that's not bad. Okay, give me a thumbs up if you're following along nicely. Give me a thumbs down if you're feeling a bit lost. Okay, now let's have a look. Let's not do that. Let's do this one. Let's do C. So in question C, I want you to find me the pink one, the green one, and the blue one. See if you can find me those three things. Those three values. Notice how there's an angle on the outside of the triangle. We call this the exterior angle of a triangle. So that's the exterior angle of the triangle. And it also looks like it's on a straight line. I think I would probably try and find X first, but there are different ways of doing this. Now I want to know what X is, Y is, and what Z is. Okay. So I think that I know that I have a straight line. Straight lines are a bit like triangles. All the angles on a straight line need to add up to 180. And so we'll go 180 minus 118 to get whatever X is, which is going to be 62. And we say angles on a straight line. Now, what is Y going to be? And what is Z going to be? That's the next question. Well, I see that there's two little whiskers on the triangle, which means that these are the same length, which means this angle and this angle must be the same, which means this is 62 degrees, and that's angles opposite equal sides. And then the final one is Z. What is Z going to be? Well, you've got two sides in a triangle. So to get the third, you just go 180 minus 62 minus 62. So sum of angles in a triangle. And what do we have there? who can help me with that? I see Morgan and Morgan has got the answer there. It seems to be 56 degrees. And what we notice is if we add up the 3, we get to 180. Annie agrees with me, and so does Hawaii. Okay, so as we go into this topic, we want to make sure that the basics from grade 9 and grade 10 are definitely in our heads. And what I want to encourage you to do is, if you're feeling lost, please do ask a question, because I'm assuming that for the most part, this is feeling familiar to you. So I'm going to keep moving with this. Okay, now, let's have a look. Okay, now I want to talk about something else before we take our break. When we have lots of lines crossing each other, what we sometimes do is we add these little letters and we go 1, 2, 3, 4. And what that means is the vertex there is P, and these angles are called P1, P2, P3, P4, and so on. And the same thing could be done over here, where we say Q1, Q2, Q3, Q4. Now, I'm going to tell you that this angle over here is going to be given as, let's have a look here. I'm going to make this to be 75 degrees. I want to know what is the value of P1, what is the value of Q4, the angle Q4, and what is the value of the angle Q1. And there's one really important thing that is, what does this mean? There are these lines, and they both have arrows. I want to know, what do those 2 arrows mean? And what things could help us? I'm giving you the angle in red. I'm saying that R4 is 75 degrees. I want to know what P1 is, and I want to know what Q4 and Q1 are. Okay, Tandeka says they are parallel. Morgan says we can use the fun methods. I think you're onto something there. I think some of you will remember the Z shapes, the C shape, the F shape. So that's good news. You've recognized that the 2 yellow lines are parallel lines. And then we call this line, it's like, sounds a bit like, it's called a transversal. And it cuts 2 parallel lines. But there's another transversal. This is also a transversal. But anyway, they make the fun shapes indeed. Now I want to know, what is P1 going to be? What is Q4 and Q1 going to be? I'm going to say that P1 must be 105 degrees. And the reason it must be 105 is that these 2 angles are on the same straight line. So 75 plus 105 gives me 180. Now, what do we think Q4 and Q1 are going to be? So Tegavatso, how did you know that Q4 was 75 degrees? You're correct, but how did you know? Annie agrees. And Tandeka, then what is, okay. I want to know, how do we know, what piece of information are we using to figure out that those are 105? Aha, yes. Okay, so it depends which one we're looking at. The 105s are called corresponding angles. Okay. And if I went between here and here, these are called co-interior angles. Okay, so the relationship, maybe I should just do it like this. The relationship between this and this is co-interior. The relationship between this and this one over here is corresponding. And that's another topic that you need to remember your fun shapes and your parallel lines for this topic. And so I just wanted to do one question where we looked at that. Let me add one more. What is Q3 going to be equal to? what is the angle Q3 going to be equal to? That's this one over here. So it is indeed going to be 105 degrees. Yeah, and there's a couple of ways we could have done it. We could have said that these two are alternate angles, the Z shape, or we could say angles on a straight line add up to 180. And that will also do it. Or you're quite right, Hawaii. That is a vertically opposite angle. And so you can get that to be 105. Okay, cool. I liked what I saw there. Give me a thumbs up if you felt like you followed everything so far. Give me a thumbs down if you feel a bit lost and going too quickly. And then we're going to have a little break. Okay, everyone. Well, then we are going to do some break time. So what I want you to do is I want you to stand up with me. And I want you to turn your cameras. I want Kia to see your lovely faces. I want to see your lovely faces. And we are going to do some stretching. So stand up, and I want you to shake up your arms. I want you to pretend that you're made of licorice, and you can just bend like this. And I want you to bend your legs, kick out your legs. And then I want you to roll your arms, roll your shoulders. Roll them back, then roll them forward. Okay, and then let's do some small circles. Going backwards into bigger circles. And then I want you to change direction, small circles into big circles. Okay. And then shake it out again. Shake it out. Okay, then I want you to do something different. I want you to breathe in, breathe out, click this finger, then click this finger, and then clap. Okay, so we're going to go. One more. Okay, then let us do 50 jumping jacks. So make sure you've got some space around you, that you're not going to whack anyone over. We want to just get our heart rate to jump up a bit. And we're going to go in 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And sit on down. Cool. I hope your brain feels better. Let me know in the chat if you just feel sore or if your brain does indeed feel better. I am going to, we normally do a little mental puzzle, but because we're short on time today, I'm going to give that a miss. But I do hope that you are feeling a bit more unwound and that you are ready to rock and roll for the second part of the lesson. Okay, now, when we go back to triangle land, when we deal with right angle triangles, there's quite an important theorem or fact that we need to know. And I want you to tell me, if we talk about something called Pythagoras' theorem, which of these 4 options do you think represents Pythagoras' theorem? Which of these 4 options do you think represents Pythagoras' theorem? Pop your vote in the chat. Let's see it. What does Pythagoras' theorem really say? Maybe somebody can come online and tell us. What do we think Pythagoras' theorem says? I know the side opposite the right angle is important. We call that the hypotenuse. So when we do Pythagoras, we know that the hypotenuse squared, in this case, it would be c squared, should be equal to the other two sides when they're squared and then added together. So c squared equals a squared plus b squared. Which of the four options is there? C squared equals a squared plus b squared. And so this would be the correct option. So this is a very important theorem in this topic. And so it's important that we know how to use it. So I was just checking that. So why don't you, let's go to another one, a little harder than that one. I want you to do this one over here for me. Find me the value of x in this triangle. Find me the value of x in this triangle using the theorem of Pythagoras that we just wrote about. Which is the important side for Pythagoras? That's the important bit. So I know this is the hypotenuse. So I know 10 squared must be equal to 8 squared plus x squared. And I must give my reason, Pythag. But now the problem is the x squared is not by itself. And to get it by itself, do that. And that leaves me with what? So 100 minus 64, that leaves me that. So what's x going to be equal to? I think we need to square root both sides. So if I've got an x squared and I want to undo it, I need to square root both sides. And then I should get x is 6. Yeah, looking good to me. Okay, so remember with Pythagoras, it's really important you know that hypotenuse is. You square that one, that's equal to the other two sides when they're squared and then added together. But it matters which one is the unknown as to how you do the stuff after that. Cool, looking good, Masejo, good, looking good, Michelle. So let us not do too many of these. I want you, this is another multiple choice question. You need to calculate the area of this triangle here. Calculate the area of this triangle. Now, if somebody is feeling very generous, maybe they can put their hand up or they can put in the chat, how do I find the area of the triangle? How do I find the area of a triangle? And then after I know how to find the area, how do I, what in this question, they're giving me 4 options for the area. Which one do you think it is? So I've got 2 sides, but I haven't said anything about the area of a triangle so far. So Tabiso and Mbali and Zanelli have said to get the area of a triangle, it's half base times height. I totally agree. But now when we talk about the base, so half base times height, what makes do we have the base and the height here? So from what I remember from school, the base and the height are at the right angle. So if this was the base, then I would need this as the height, or if this was, or vice versa. So the problem we have now is we don't know what the green side is. Would anybody be able to work out the green side for me? What are we going to use to find the green side? Yes, Tando, you're on the money. It is Pythagoras because it's a right angle triangle. So we know about the relationship. So I'm going to give you some time to figure out the green side for me. and then make your decision about which of the 4 options do you think is correct. Okay. So I know that 25 squared. Now I'm going to give it a letter name because it makes life a bit easier. I should just call it x plus x squared. And that's by Pythag. Now I might need to use my calculator here. And some teachers actually do all the working out first. And then they just put the final answer in there. And it seems to me like students are saying that this length over here is 24. So x is 24. Now, once we know that that is 24, and that's correct, we need to figure out the area for this. So which of the 4 options are we going to choose? So I know the area half, and then 2 more things. So 7 would be 1, and then 24 would be the other. And you may need a calculator at that point if you, just to be precise. So we go, well, I get 84 centimeters squared. And so if I get 84 centimeters squared as the area of my triangle, the correct answer is going to be A. Are there any questions or comments about that? I don't want to lose you. So there was 2 important ideas. To find the area of a triangle, we first remembered that the area of a triangle is a half base times height, but the base and the height have to meet at the right angle. And so we had to use Pythagoras first to work out the length of the height of this triangle. And so I just want to give a moment in case any students want to raise a question or a comment, or if you're feeling, I'll just give a second for that. Okay, I'm assuming that everything is okay. All right, ladies and gentlemen, we are moving on for Pythagoras. We're now in this land where we are trying to find this missing side A. But this is getting a little bit more interesting. We need some more tools in our toolkit. Maybe we were using a hammer and then we used a screwdriver, but now we need to use something new. Now, what are we given in this? We're given a triangle, we're given a right angle, but we're given a different combination of information. Like we're actually given an angle over here, and we're given a side over here, but they want to know what A is. And I'm wondering, in your learning of mathematics, what tool do you think I'm going to use here? Because I can't use Pythagoras, because normally with Pythagoras I would have 2 sides, and I can't use. I suppose I could work out what this is, right? But then the question is asking me, what is the length of side A? So I want to open this to the floor and ask, what area of mathematics do you think I'm going to use here? I'd love somebody to give us a hint. If we can't get a hint, I'll step in. But I want you to think back to last year. Was there any toolkit? Masejo, the magic word, trig. Yes, trigonometry. And trigonometry is all about ratios always being the same. And there's a quick way of remembering the different ratios. It's called SOHCAHTOA. And when we talk about SOHCAHTOA, we talk about the opposite side being the opposite an angle, and the H being the hypotenuse, and the A being the adjacent. And so going back to grade 10, just to do a quick little refresher, in this particular triangle, we would call this side big H. We would call this side over here O, because it's opposite the 31, or the angle that we know. And then we'd call this side over here A for adjacent. Give me a thumbs up if you remember the idea of SOHCAHTOA and you remember the idea of O, A, and H. Give me a thumbs down if that's the first time you've seen that and it's feeling all a bit confusing. Okay, now, we need to figure out what this length is over here. Which trig ratio do you think we are going to use to figure out this A value? Because there's three of them. The one trig ratio is sine. The other trig ratio is cos. The other trig ratio is tan. And at the moment, I haven't said much about this. I'm kind of relying on grade 10, but I'm just curious to know, what would you look at? Well, you want this side and you know this side. So the two sides that are important to you are A and H. And so A and H involve the trig ratio cos. So what you do is you write the cos, and then you write the angle that is given in the triangle. So cos of 31 is equal to A, and this is big A, but it's, over here goes with little a, over 16. And so we say the cos of 31 is equal to A over 16. Then, in order to get A by itself, I need to multiply both sides by 16, or I need to move the 16 over here to that side, and I get 16 times the cos of 31 is equal to A. Which of the four options do you think is correct? So if the length of A is equal to 16 cos 31, which of the four options do you think is going to be correct? I can punch it in my calculator if I need to. So I go 16 times the cos of 31, and that is equal to, it seems, 13.71. Now remember, you were solving for the length of a side, and 13.71 is A. So what were the key steps that I used? Now, right throughout today's lesson, I've been solving for unknown angles and unknown sides. In this question, I had a right angle triangle. Because I had a right angle triangle, I could label the sides using O, A, and H. I then looked at what I wanted and what I knew, and I found the correct trig ratio for that. I wrote it down, and then I solved for the A value that I was looking for. Now, again, if you are unsure about doing this, it's a good idea to maybe look at some of Watobe's grade 10 stuff on this. But we're going to practice one more now just to kind of make sure you're in the mood for this. Okay, here's the question. You're doing it all by yourself. What is going to be the length of side A? And if you're unsure, I encourage you to raise your hand to ask an audio question or to pop a question in the chat. I want you to try and find A. What do you think A is? Maybe I would start by labeling. I know that's an H. Now you've given this angle here, so I guess this would be called an O in the big letter sense, and then this would be an A. And I want this one, and I'm given this one here. So it feels to me like the trig ratio that I need, and it might be helpful to write these out, SOHCAHTOA, it feels to me like the O and H is involved in this one. And so we'd write the sine of 64 is equal to, in this case, it's just going to be little a over 10.8. But now I still need to choose the correct option, and I need to bring this 10.8 to the other side. So that needs to go here. And then I have to choose from the 4 options. What do we think? Which one do you think it's going to be? I get 9.71, 9.71, which means the correct answer here must be C. Okay, I just want to pause for a second and see if there are any questions or comments. Again, look at all the tools. Today has been all about looking at what are the tools we have in our toolkit for solving for unknown angles and unknown sides if you're given triangles. And this last little bit, when we deal with trigonometry, it's been dealing with right angle triangles specifically, because then we can label the sides O, A, and H and use our SOHCAHTOA acronym. Okay, let's leave that for now. That's fine. We don't need to do that. In fact, I think we're actually pretty much done for today. Let's pause at this stage, and I want to pause and see, are there any questions or comments about today's lesson? Otherwise, if there are not, here, if you can put the poll up for today's lesson so we can get a sense of how the students found, if it was too quick, too slow, etc. Are there any final questions or things you want to know about in terms of triangles? Because in the next lesson, we're going to focus on what tools do we have for solving for sides and angles when we have non-right angle triangles. And so I just want to get a sense of how we are feeling about the lesson today. But yeah, and if there are any final questions, that would be super helpful. How did I get the answer? So I put into my calculator. Okay, so if you think about the sine of 64 is a divided by 10.8, I really want to get this 10.8 to the other side. And what happens when I bring it from this side to the other side is it becomes a multiplication. So I literally type in my calculator 10.8 times sine 64 close bracket equals, and then I got 9.7 there. Mbali and Zaneles asked, why did we use SOHCAHTOA? Okay, so the reason we used SOHCAHTOA is that the question got harder. If you think about what we did in previous lessons, in previous questions in today, we would, in this question, we don't have a way of finding this side using the tools that came before. We could find this angle over here. We could go 180 minus 90 minus 64 and get that. But we wouldn't be able to use Pythagoras because Pythagoras needs 2 sides. We would have needed to have another side before we could have used 2 sides to work out the third side. So that's how why we had to use that. So Annie has asked, how do we know whether to use sine or inverse sine? So I'll talk a little bit about that in the next lesson, Annie. But basically, when you're solving for sides, you use the normal trigonometry. When you're solving for angles, you use the inverse trig function. Okay, so, but today, when we were talking about trig, we were only solving for unknown sides, and that's all we did there. Okay. Fantastic, everyone. Love the questions. Remember, today is just lesson 1. We were just getting the engines warmed up. going to still spend lots of quality. Okay. And so Michelle has asked, Michelle, you use the fun method when you see parallel lines. So at the moment, we just see triangles, but sometimes, and that was just a bit of revision, but sometimes you could have like a situation like that, I guess. And if these lines are parallel, it's just important to remember that the fun shapes can be used. But most of the time in this section, they don't come up that often. But I just wanted to kind of just get your brain back in the mood. So Morgan has asked, do we decide what is opposite, adjacent, hypotenuse based on the right angle? Okay, so actually the right angle just tells us where H is. The more important bit is the angle that you're given. So if you're given the angle other than the right angle, this is actually what decides where the opposite is, which is opposite the angle you're given. And then the only remaining side is just going to be the A. So it's actually, this is the boss here. The angle that's inside the triangle that's not right angled tells me where O is. H is always stuck opposite the right angle. Okay, so I hope that helps.